finally, let's discuss how TCP handles reliability. So TCP uses cumulative ACKs, which allow detection of dropped packets. How does this allow detection of dropped packets? Well, one way is we don't receive an ACK. If we send a packet and we don't get an ACK back, that means that some packet was dropped. Now, it could either be the data packet, in which case we should resend the data, or it could have been the ACK packet that was dropped, in which case maybe in an ideal world we wouldn't send the data again, but we have no way of distinguishing those two cases, whether it was the data or the ACK that was dropped, from a single ACK, from a single data packet being sent. Conveniently, subsequent ACKs that are received can tell us more information. So if we don't get an ACK back for some data, but the next ACK, here cumulative ACKs, the next cumulative ACK received acts further along, that means that the receiver did receive that data that we didn't get an ACK for, and the ACK must have gotten dropped on the way back. Because if the receiver sends ACKs further along with higher numbers, cumulative ACKs, that means that all previous data has been received. Whereas instead, if the receiver were to keep sending back ACKs, which, remember, have a sequence number in them that says, a sequence number in the acknowledgement field that says, this is the next byte of data I'm looking for, if the ACKs have the same value each time, meaning that the receiver is waiting for this particular piece of data, that means that packets are continuing to arrive, but the same data is being requested, and so we should probably resend that data. It probably got dropped. So, zooming in on this timeout. We have this value, abbreviated RTO, which is the retransmission timeout. And this is the timeout after which we should retransmit our packets. And in these real TCP implementations, this is constantly being updated based on what we measure the current round trip time to be. Now, the reason we do it this way is because we need to pick some value for when to retransmit. And if our value is too low, meaning we retransmit once this timer runs out if we haven't received an ACK, if that value is less than the round trip time, then we're going to constantly be resending packets and then immediately getting an ACK because we just didn't wait quite long enough. And so the receiver is going to receive duplicate packets. Every duplicate packet just gets dropped. It's a bit annoying. On the other hand, if we pick a really large number for our timeout, then when a packet does get dropped, it takes us a long while to recover. And ideally, we'd be able to pick a single number in between that's just right. But every connection is different. So if I'm talking to someone from here in Berkeley to someone down in Stanford, that round trip time is pretty short. Whereas if I'm talking to someone in Ukraine, that round trip time is quite long. And so we need to adjust our retransmission timeout accordingly. And the way we do this is using a constantly updated RTT estimate and an estimate of the average RTT and of the variance on the RTT. And using these two things, we can compute some retransmission timeout value. I'll point out in TCP, this is a single timer, not per packet. What this means is that every time we receive a new ACK, so an ACK of new data, this resets this RTO value. As soon as this RTO value does time out, we retransmit just the packet containing the next byte. Not the whole window as we did in go back in, but just the packet containing the next byte. It should be the first packet in the window. I kind of pointed this out a second ago. The RTO is too large. We will just wait a long time. Now, the other thing we could do is be smart about looking at duplicate ACKs. So duplicate ACKs are a way to tell that my data, probably if I see a bunch of ACKs of the same value, like here, 3000, 3000, 3000, 3000, probably the data sequence number 3000 got dropped. And the subsequent packets are all making it because every packet that arrives causes the receiver to generate a single ACK. So this is a good sign that we should try to resend soon. In fact, the scheme of resending based on duplicate ACKs is called TCP fast retransmit. I don't think we've talked about it in lecture yet, but I expect we will soon.